This video is on Leibnitz theorem, and if you look at this pattern, we want to know how this thing came to be. You see, the nth derivative of two functions nc, you have u here, the n dv, okay, then plus you have nc1 du the n minus 1 v plus nc2 the squared u n minus 2v and all that. Don't worry about how it looks like. Let me explain. So let's say we have two functions, y is equal to uv, and all of them are as a function of x. So I will take differentiation of them with respect to x. So if you differentiate the right side, you keep the first one using the product rule and find the derivative of the second one, which is dv over the x. So we are going to keep the second one and find the derivative of this first one, which is du all over the x. So this is the first derivative of uv, which is the two functions that could be anything at all. So let's look at the second derivative of the function, d squared y over the x squared. Okay, let's look at the second derivative. I can write this into be d over the x, okay, multiplied by dy all over the x, because if you open the bracket, you will still get back what you have. D times d will give you d squared and y, and the x times the x will give you the x squared. So you notice that we have the same thing, but we already have or know what dy dx is from the last derivation. So dy dx is the same thing as what we have here. So let's replace dy dx with u dv over the x, then plus v du over the x. Then I'm going to differentiate the bracket again using the product rule, the same way I did in the first example. Okay, so let's do that. With respect to x, so I will start with this bracket part because there is where I'm going to differentiate. So I will keep the first function, which is u, and take the derivative of dv over the x. D times d will give you d squared, okay, and I'm going to have the s times the s will give you the x squared. So this is d squared v over the x squared. I kept the first one, differentiate the second one. So let's keep the second one, which is dv over the x, and differentiate u. So d times u will give you du, okay, d times this u will give you du all over the x we have outside the bracket. So we are done with the first one. Plus I'm going to keep the first one, which is v, and multiply that with derivative of the second one. D times d will give you d squared u all over the x times the s will give you the x squared, okay, then plus, remember we kept the first and differentiate the second, so I'm going to keep the second, which is du over the x, then differentiate the first. D times v will give you dv all over the x, so it's just dv over the x when you differentiate v with respect to x. So we are done with that. If you look at here, we have this function and this function to be the same thing. So when you add the two of them together, let's repeat what we have. This is u d squared v over the x squared, bringing down the first term, okay, then plus this will give you 2 of du over the x, then dv dx, okay, then plus I will bring down this term v d squared u all over the x squared. So that is it for the d squared y over the x, which is the second